Hello and welcome to the next lesson, which tackles production functions, and this more specifically looks at production functions in the short term. In the last lesson we looked at production functions in the long term. Okay, this is the statement of the learning outcomes for this particular lesson. We have 8 slides altogether, including these first 2. And then we go over to yourselves to tackle 3 multiple choice questions. We're going to be comparing the short term and long term, looking at a contrast between them. And then we move on to look at the law of variable proportions, which applies to the short term only. We look at the shape of the short run marginal product curve, and then the relationship between that and the average product, and also total product, which is our production function in the short term. And finally, for this presentation, we look at the journey as a whole that we are on in moving from production, where we are now, to deriving cost functions, which will come up in future presentations, and then looking at revenue functions. And once we have, of course, costs and revenue, we are able to look at how firms maximize profits and the output level that will help them to maximize profits. So that's where we're going. Let's move on to the first of the slides of today's lesson. Okay, what about the short term? Let's start off with a contrast by reminding ourselves of the long term. And this we looked at in the last lesson. We had a 2 axes, and we looked at 2 factors of production, labor and capital. We are able to vary both, as shown by the increase from capital 1 to capital 2 and labor 1 to labor 2. And then we were able to say, well, a firm may want to move from production of 500 cookies per day along this ISO quant to a new ISO quant of 1,000 cookies per day. And the total product curve here traces out the path that they follow in deciding on how much capital and labor to use, depending upon relative factor prices. In other words, the price of labor compared to the price of capital. And firms will choose the least cost method of production. Okay. Now in the short term, of course, we still have some key variables like output. We still have resources, the same resources in fact, but at least one of them, and we normally assume capital and land, to be fixed in supply. Though the technical definition of the short term is that only one minimum has to be fixed in supply. We usually regard labor as being our only variable factor in the short term. So the firm now can no longer vary capital. So therefore the concept of economies of scale is not relevant. The term scale always applies to the long term. So if you have any question in multiple choice exams about diminishing marginal returns, about the short term, any answer relating to the word scale can be eliminated immediately because it's not relevant at all. It's a long-term concept, not a short-term concept. To increase output now, our firm producing cookies or cars, computer software and so on can only increase the variable factor, which is labor. That means that they can't move from capital 1 to capital 2, which kind of makes it pointless having capital on the axis here. So we're going to remove capital and replace it with a new variable, which will be output, in other words, total product. So we're going to have now a short-term relationship defined in space where we have labor on the x-axis and output on the y-axis, because we cannot vary capital nor can we vary land. Okay, here we have our delicious cookies still there, still being baked. We have our fixed supply of capital. In the short term, we cannot vary capital if we want to increase production. We still have our loyal chef. Now, if we want to produce more cookies, we can't increase capital. all we can do is increase labour, so we're going to have an extra chef. And now we have a different proportion of labour to capital. Before we had 1 to 1, now we have 2 to 1. Can 2 chefs be as productive with one oven as 1 chef per oven? That's a question that we have to ask. Let's say we want to expand even more because demand is high. It could be a weekend, could be a holiday season. We want to produce a third batch of cookies. What can we do now? I'm afraid we cannot increase capital. We can go from 2 chefs to having 3 chefs. And again, the proportion of labour to capital has changed. It's now 3 to 1. Can our third chef add as much to output as the second chef? And that's a very important concept. We're going to look at how, as we vary the number of chefs, the total output of cookies will change. And if, for example, let's say that you, with the first chef, we produce 20 cookies altogether, and having a second chef allows us to produce 50, the second chef has added 30 units of cookies to our production. That does not mean that he or she is more productive in themselves than the first chef. They don't necessarily have more skills, we assume that to be constant, but rather by having greater specialization, we are going to find that the second chef will add more to output than the first chef. The third chef might add, but possibly a bit less because too many cooks spoil the broth. 3 chefs to 1 could mean that there's overutilization, and that concept we come back to in the near future. Okay, so here we have varying proportions of labour and capital. Because we had 1 to 1, now we have 3 to 1. How will this affect the productivity of labour? That's the key question that we have to ask. The ratio of capital to labour now has changed from 1 to 1 to 1 to 3. 3 units of labour for 1 unit of capital. That relates to the variable proportions of factors of production. How will that affect the productivity of labour? And now let's move on to the next slide. Here we have our new graph defined in the space of having 2 variables. We have a variable factor labour, and we have output over here. Remember, we cannot vary capital or land, so there's no point in having them on the axis. Here we have, let's say, a possible production function. As we increase the amount of labour, then output increases, and this TP stands for the total product or total output. And this is one possible production function. Okay. In this case, what happens? Well, we're going to be looking at the horizontal change, which measures, looking at the horizontal axis here, an increase in labour unit by 1. In other words, let's say we add 1 more chef to the production team. So here we have the addition of 1 chef to our production team. This is shown as a change in labour. Okay, a change in labour. And then we can say, well, okay, that has an impact upon output. Output increased by this much. So the purple line will show us the change in total product. And this together will show us what? Well, it shows us the change in total product as we change the units of labour by 1. And this is a very, very important variable. It's called the marginal product of labour, and is sometimes shown with an extra P, where we have the marginal physical product. Marginal physical product shows us what happens to output if we increase the units of labour by 1 unit. Now in this case, if we then increase our labour by another unit equal to the first increase, in other words, we add 1 more chef, what happens to our output? Well, it's exactly the same in this case because we have a linear curve here. As we increase labour units by 1, in each case the output will increase by the same amount, shown here by the purple line. So what that means is that the marginal physical product is actually constant as we move up along the output curve. As labour units increase, not only does output increase, that's pretty much expected to a large extent, but the increase in output will be constant at every single point. So we say that the marginal physical product is constant in this particular case. I'm not saying that reflects reality. I'm not saying that economic theory tends to believe that or support it. It doesn't, to be honest. But this is the kind of baseline, and we're going to compare that to two other possibilities and then derive what is commonly shown in the books of economic theory as being the short-term marginal product curve. Right, let's remove the annotations and look at an alternative. Here we have an alternative. We're going to call this total product 2. Now again, we're going to have an increase in our units of labour, and let's assume that's still 1 unit. So we have change in labour over here, and what happens to output? Okay, what happens to output is that you have this increase in output shown on the vertical axis. Now let's increase our units of labour again by the same amount, in other words by 1 unit. Now in that case, output will actually increase by more. So this purple line here is actually more than the first purple line, showing that the output increase from the same increase in the units of labour is actually more than it was before. So if we write over here, change in total product. Okay, now who remembers what we call this? We call this what? I'll wait for a couple of seconds. We call it the marginal physical product. Marginal physical product. This now is actually increasing as we increase our units of labour on TP2. As we increase labour units by 1, we get ever increasing amounts of output out of the extra labour. Not because the extra chefs and so on are more productive in themselves, they don't have more skills, we assume that to be constant, but rather there's a reason we're going to be looking at related to greater specialisation of the fixed factors. So marginal physical product will actually stay constant along TP1, but it will actually increase along TP2. And now we have a third alternative to look at, which is TP3. And here we have the opposite of TP2, as you might have guessed. We're going to increase the amount of labour units by 1 yet again. And then we're going to see what happens to output. Okay, so we're going to have over here a change in the labour units, and you've got it. I think you remember that now. The numerator will have the change in total product, and this equation gives us what again? It gives us a marginal physical product. Let's see what happens now along TP3. Okay, so we have another increase in labour units, also equal to 1 plus 1. But now you can see, I hope, that the increase in output is actually less in the second case over here than in the first case. Less over here than there. And that means that although output is increasing as we increase units of labour, you know, we're not saying output falls here. When we have more labour over here, output is increasing. The curve is actually upward sloping. However, the increases in output start to fall, and therefore we say that the marginal physical product will fall as we increase the amount of labour along TP3. Now there we have 3 different possibilities. What does economic theory support? Does it support TP1 or 2 or 3? And actually what happens is that we tend not to support TP1 at all, but we include TP2 and TP3 and combine them into one total product curve, which will have different gradients, different slopes at different amounts of the variable factor labour. Let's see how that works out. So we're going to remove that. Let me get rid of the annotations as well. And we're going to get rid of all of those. And this will be effectively our total product curve. So let's just call it, let's say TP, if you like, TP4. This is our total product curve, showing that we have different stages. At low levels of labor, as we increase the amount of labor, we get increasing marginal product. Y comes up in the next slide, God willing. And then at higher stages over here, as we increase the amount of labor, we're going to get smaller and smaller increases in the output, as shown by the vertical distances. And that will continue until it pretty much gets to zero, in fact. And we can even extend the total product curve. It'll look something like that. It may even fall as we keep on piling more and more labor into that kitchen using our one oven. And I think you are getting the picture now of why we have this kind of shape. Just to sum up, initially we have rising marginal product as we increase the variable factors, and then we get to a kind of peak of marginal product, and then we get to a stage where adding more and more labor units will in fact cause falls in marginal product, until eventually, when we get to the peak of the total product curve, the marginal product will in fact be zero. We've added nothing extra to output by having one extra chef, and thereafter piling more and more chefs into the kitchen will lead to falling output, in other words negative marginal product, by adding more labor. Okay, we're going to move on now to the next slide and try to explain with a kind of picture and link up to economic theory to explain the shape of that curve. Why do we get rising marginal product and then falling marginal product? What's the logic behind that? Well, imagine we have our whole kitchen space here represented by the factor land, and we have our capital stock, which includes, for example, I think we have a workstation there, we have 2 ovens. Okay, this is where we have the chopping board and food preparation. We have food processing, of course, in the ovens over here, and we have initially only 1 chef. So effectively we have rather a lot of capital and perhaps not enough labor. In other words, the 2 ovens and workstation are likely to be underutilized by the 1 chef. It's unlikely that the 1 chef can fully utilize those fixed assets. They're not going to be sweating, as I say, they're not going to be working 24/7 because the chef is kind of overworked. So the capital stock here is going to be underutilized, as is stated here. Now, what are the consequences of that? Let's keep on adding more and more labor when the fixed factors are underutilized. So we have a couple of ovens, a workstation, maybe half of that workstation is not being used. It's kind of lying idle, as we say, and possibly even 1 oven is also lying idle. So let's put a question mark to show that those fixed factors are idle and these are being utilized. So overall the fixed factors are underutilized. What happens then when we have 1 more chef? I've got a summary here. Now please at this stage focus only on the circled area here upon the first column. The fixed factors are underutilized. That's the stage that we are at. Now what happens when you add more labor? What's the effect upon total product, upon TP? Well, you can now have more specialization. Okay, our extra chef, for example, will be able to take part in helping the first chef in food preparation, while the second chef focuses upon working in the oven and making sure the cookies come out at the right time. Okay, so you now have greater specialization and total product will rise at a faster rate, and that explains why the marginal product increases when you have low amounts of variable factors, because by adding more variable factors you can have more and more specialization, and therefore the marginal product will increase. Now let's say that you need to produce more cookies and you want to work out what will happen to total output when you have your second chef. Again, Now we've got to a stage where, let's say, the fixed factors are fully utilized. Okay, none of these fixed assets now are lying idle. They are fully utilized, but not overutilized, neither under nor overutilized, just right. You have just the right proportion, if you like, of labor to capital. We have varied the proportions, but now you have effectively the most appropriate proportion where the fixed assets are fully utilized. Let's look now at the second stage over here, and we're at that stage there. Okay, what's the impact now on total product when you increase the amount of variable factors? Well, the marginal product will actually get to its peak. Okay, the marginal product will get to its peak, where you can't increase the output at a faster rate. You can't increase the output at a faster rate because you've got to the effectively maximum productivity. Total product will continue to rise, but because the fixed factors are fully utilized now, adding more labor will get to the maximum value of marginal product. And then we have a situation where we still need to keep on increasing our variable factors to produce more, and now we get to a stage where we have almost too many chefs, too many cooks spoil the broth. Broth means soup. That's a saying that we have in English. Too many cooks spoil the broth. So we have here a situation of 3 chefs and only 2 ovens and 1 workstation. The capital stock now is inadequate, insufficient for there to be effective production, and productivity will start to fall. How do we show that? In the third stage over here, where we have fixed assets being overutilized. And now if you increase the variable factors even more, what happens? Well, total product will continue to rise. We will produce more cookies initially. So marginal product at that stage is positive. However, the marginal product starts to fall, and that's where we get to the stage in the total product curve of a falling gradient, where the marginal product gets less and less and less before peaking. There may even come a stage when you keep on adding more and more labor over here, when you have 6 chefs and 7 chefs and 8 chefs, that the fixed factors are completely and utterly overutilized, and at that stage you have all the chefs getting in each other's way, and total product might even fall as you keep on adding more chefs. In that case, the marginal product will become negative. Okay, now just in preparation for showing more graphical analysis, I'm going to convert this table into a kind of graph. So there we have the axis, there we have the x-axis over there, there we have the origin, and here we have the 3 stages over here. So we're going to move from stage 1 to stage 2 to stage 3. Here we have at low levels of the variable factors, and here we have of course labor, here we have output, labor and output. So as we are at the first stage here, where fixed factors are underutilized, when we increase the amount of labor, the marginal product will rise, as we saw in the previous slide. We then get to a stage where the marginal product can't rise anymore, and that's when the gradient of the total product is at its highest. If we keep on adding more and more labor, we get to the third stage where the fixed factors are overutilized, and therefore the output will increase, but marginal product will decline until it gets all the way down to 0. And if we were then to increase labor even more, the marginal product curve will go below the origin, and total product will actually fall as we produce more. Okay, that completes this particular slide, and now we're going to look at the marginal product curve in more depth and its relationship with average product and total product. So now we're going to look at the relationship between 2 very important variables, marginal product and average product. And as we saw, the equation for marginal product was the change in, who remembers? Should I wait 5 seconds, give you guys a chance? Okay, here we go. Okay, time's up guys. So here we have the change in total product divided by the change in the units of labour. Which one is that? That is marginal product or marginal physical product. Now what's the equation for the average product? Let's put that in a different colour. The equation for average product will be the total product divided by the amount of labour being used, and that gives us the equation for the average product. And it's useful to remember these equations. Okay, so you may want to just jot them down now. I'm going to remove them so we can use the space more effectively. Right, here we have some kind of numbers to give you guys a feel. When you're writing out answers in examinations, don't refer to fictional data. If they give you data in a table, then of course you should refer to that, but don't make up your own data. They prefer normally to have more conceptual answers. Here we have the amount of variable factors, in other words, the amount of chefs. We had 0 chefs. Okay, what happens to output? Well, we produce nothing. We can't calculate these two variables. Now let's say we add 1 chef and all of a sudden we have 20 cookies. What's the marginal product? The difference between output at 0 and output at 1. Output at 0 and output at 1. Let's just quickly write in the equation here. Change in total product divided by the change in labour. The change in labour in each case is going to be 1. We're going to move up in ones over here to keep it simple. Okay, but the change in total product we get from this column here. So for example, let's look at why this is 30, because when we increased our units of labour from 1 to 2 over here, output increased from 20 to 50, and therefore the marginal product is the change in output over here. 40 is calculated as 90 minus 50, 40 here calculated as 130 minus 90, 35, 165 minus 130, and so on. The average product is calculated as our total output divided by the units of labour. So average product over here we calculate from total product divided by the amount of labour units. So if we can just number these columns over here, 1 and 2, I'll leave out MP for now, I just gave you the equation there. Average product will be column 2 divided by column 1. So let's say over here we have total production of 90, and we have 3 variable factors or 3 chefs. Therefore the average product will be equal to 30 over here. I hope that's clear. Now these are the graphs. You are familiar with the shape of the marginal product curve from the previous slide. So marginal product will rise because of greater specialization of labour, and then fall because of overutilization of fixed factors. And we actually have a name for this particular stage over here. It's very critical. Let's just write out the first stage over here. Here we have what? We have increasing marginal returns. So here we have increasing marginal returns. Okay, I'm just going to write the word increasing there. Increasing marginal returns. And here we have the maximum marginal returns given by the maximum point of marginal product. And thereafter, once you pass that maximum point over here, all points to the right, you have decreasing marginal returns. This is not decreasing returns to scale, because here we are dealing in the short term, whereas economies of scale deal in the long term. So any point to the left here we have increasing marginal returns to labour, and to the right we have decreasing marginal returns to labour. Okay, decreasing marginal returns to labour. What do we have on the axis here? We can say MP, or we can write AP, marginal product and average product. And this relationship between marginal product and average product is very, very important. It's important for understanding the general theory. because now we've explained to you what happens over here, increasing marginal returns, over here from this point on decreasing marginal returns, and notice that decreasing marginal returns start from here, not from the maximum point of average product. They start from here. This point of intersection occurs at the maximum point of average product, and you must draw it in that way in examinations to avoid deductions. The maximum point of average product occurs at the point of intersection with marginal product. There's a reason for that, and it's a mathematical relationship between marginal and average. Imagine, for example, that over here, which one's higher, marginal or average? Marginal. So therefore that pulls up the average. Whenever the marginal is higher than the average, it will increase the average. And that can be seen here. At this point the average product is 30. You then have the next unit of labour adds 40. Well, now the marginal product is higher than the previous average product, so that will pull up the average product from 30 up to 32.5. So whenever the marginal product is above the average product, it will increase the average product. And that occurs even at this range here, where the marginal product is falling. Even here, this will pull up the average product, simply because the marginal product is higher than the average product. Once you get to this point over here, it's reversed. The marginal product is lower than the average product. As you can see here, we have 25 compared to 33, and that will actually pull down the average product from 33 to 31.7. So over here, marginal is less than average, and therefore that will pull down the average as stated here. Whenever marginal is less than average, the average will fall. Okay, right, we're moving on now to look at the relationship between marginal and average, and that's just a reproduction of the same graph from the previous slide, but now we're going to put it right underneath the total product curve, because I'd like to explain to you the relationship between marginal and average and total, to see what the relationship is. This is our total product curve. Okay, now you can see, and this takes us back to one of the earlier slides. You can see now that the total product curve, total output increases at a faster rate over here as we add more and more units of labour. Okay, total product rises at a faster and faster rate over here. Going back to our triangles, you can see output rising at a faster and faster rate, shown by increasing vertical lines there. But over here, total output will increase by less and less and less. So total product here rises at a slower rate, and that's where marginal product falls. And somewhere over here, our marginal product will be at a maximum. So marginal product rises, 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 as you can see from the points down here. It then gets to a maximum, and that will link up to that point over there. And thereafter, marginal product will start to fall, as you can see from the gradients here. You then get to the point of intersection, and marginal product will continue to fall until it gets to 0, and that corresponds to the maximum point over here, the maximum point of the total product curve. At that point there, this corresponds exactly to the point where marginal product is 0, because you can't increase output anymore. And thereafter, increasing the amount of chefs or labour in general will lead to falling amounts of output, and therefore marginal product has to be negative. Now I do advise you to look at this slide again. I hope that I've broken it down for you fairly well. At the same time, I think 2 or 3 visits to this slide will help to consolidate your knowledge and help you to work out the relationship between these two curves, in particular marginal product and total product. Interestingly enough, if you want to look at the relationship between total product and average product, okay, we said that the average product formula and it's also always useful to go back to formulae. Total product divided by output. So if you were to draw a line from the origin up to any point on the total product curve, here you have the vertical line there showing total product, and horizontally you can see the amount of labor you're using over here, so you can actually calculate the average product. And this point here, if you were to trace it up to that point and draw a line from here up to there, making it as straight as possible and tangential to the point there, that will actually be the highest point of average product. And notice that marginal product peaks somewhere over here, average product over there, so marginal product will always peak at a point before the peak of the average product. Okay, that completes the analysis to a large extent. And now I've got a few questions for you based upon the lessons so far, and we're going to kind of give you a bit of time to look at these as we go through the lesson, and then point out the answers, and then finally you have 3 multiple choice questions yourself to tackle all by yourselves, independent practice. Right, the first question: look for the maximum point of marginal product, and I mean in the total product curve. Okay, I'm going to wait a few seconds for that. We have helped you a few minutes ago, so let's see how good your memories are. I'll just wait about 5 seconds. The maximum point of marginal product. Okay, well, over here of course it's shown by this point, and on the total product curve it'll be shown at a point such as this here, where the gradient of the total product curve gets to a maximum and then starts to fall. If you were to draw tangents to the point to this curve over here at different points, you're going to see that the gradient rises until this point it gets to a maximum, and thereafter the tangents drawn to the total product curve, their gradients will fall as marginal product falls. So the maximum point of marginal product will occur somewhere over here. Next question: when does a firm start to experience diminishing marginal returns? Is it to the right of the peak of the marginal product, or to the right of the peak of average product? Again, I'm going to hang on here about 5 seconds for you to work out the answer. Hope you got it right, guys. Okay, it's to the right of the peak of marginal product. Okay, any point after that the firm will experience diminishing marginal returns to labor. Okay, and of course to the right of that point over there. Question number 3: the maximum point of average product. Of course we can see it quite easily here, and you can just draw a line going up to the total product curve somewhere over there, and that can be shown by a line from the origin, which should be a tangent to that same point. So at that point there we are maximizing the average product. Remember, average you can always calculate by drawing a line from the origin to make it tangent to a point on the total. That will give you the average. Okay. Question number 4: the intersection of marginal and average product, of course, will occur at this point here. That's a very easy one. That's when marginal product equals average product. And the maximum point of zero marginal product, well, marginal product will equal 0, of course, at this point over here, and that corresponds to the maximum point on the total product curve. Okay, the maximum point on the total product curve is exactly here, and that will correspond to 0 marginal product, because increasing the variable factors lead to 0 increase in output. Okay, I hope you got all those right. If you did, you'll be ready for the multiple choice questions. Before we get there, just one last very simple task, but quite important, I think. Planning our route. Where are we going? Where next? Well, so far what we have looked at are production functions. We've looked at them in the long term, and we have looked at them now in the short term. So in other words, as firms vary the inputs, what happens to output, and when do diminishing marginal returns cut in? And we had, of course, factors of production such as labor and capital. There's also land we tended to kind of almost forget about. If we multiply each of those factors times their price, times the factor price, the same, for example, you multiply land times the rental income that you get from land, and the same for capital with its own cost. Multiply each of these factors times the factor price, then you actually get these cost functions. And firms would like, other things being equal, to minimize their costs. Once you have that, you're halfway through. You then have to look at revenue functions. In other words, what happens as you increase output? What happens to total revenue, which we're going to call TR? Does it rise or fall? We're not going to answer that question now, but just to show you where we're going. Once you have cost functions and revenue functions, of course, it's quite easy to derive the profit function as being revenue minus cost. So then we can actually try to work out the output level that will help the firm to maximize profits. Okay, that's where we're going. And after that, we apply that differentially to different types of market structures, such as monopoly, oligopoly, and so on. Well, you guys have done tremendously well if you've hung out this far to listen to the last slide. I do advise you to go through it once or twice. It can be a bit tricky, but a solid foundation here can really help you to launch into a solid knowledge of economic theory, in particular on market structures and so on. Right now, I'm going to hand over to you guys. There are 3 multiple choice questions. If you're looking at this presentation as an embedded video, for example, you'll be able to answer those questions and see comments whether you get them right or wrong. That won't happen, of course, if you're watching it as a video, MP4 format. I wish you guys all the best. Have a great day, and all the best with your economic theory. Take care.